JEE Advanced 2025, Paper 1, Physics, Question 16. Let us first visualize how energy depends on atomic number Z for different physical phenomena. The first curve shows E proportional to Z squared, a parabola rising steeply. The second shows E proportional to Z minus 1 whole squared, shifted 1 unit to the right. The third shows E proportional to Z times Z minus 1, a quadratic that passes through the origin and through Z equals 1. And the fourth is a flat horizontal line, indicating energy is practically independent of Z. Here is the complete question. Match the functional dependence of energy E on atomic number Z, given in list 1, with the corresponding physical phenomena in list 2. List 1 has P, E proportional to Z squared. Q, E proportional to Z minus 1 whole squared. R, E proportional to Z times Z minus 1. S, E practically independent of Z. List 2 has 1. Energy of characteristic X-rays. 2. Electrostatic part of nuclear binding energy for stable nuclei. 3. Energy of continuous X-rays. 4. Average nuclear binding energy per nucleon. 5. Energy of radiation from electronic transitions in hydrogen-like atoms. The key concepts we need. First, for hydrogen-like atoms, the energy levels are given by En equals minus 13.6 Z squared over N squared electron volts. So the radiation energy depends on Z squared. Second, Moseley's law for characteristic X-rays states that the square root of frequency is proportional to Z minus B, where B is approximately 1. So energy goes as Z minus 1 whole squared. Third, the Coulomb energy term in the semi-empirical mass formula for nuclei is proportional to Z times Z minus 1 over A to the 1/3 power. Fourth, average binding energy per nucleon is roughly constant at about 8 MeV for mass numbers between 30 and 170. Let us now match each pair. P says E is proportional to Z squared. For hydrogen-like atoms, the energy of electronic transitions is En equals minus 13.6 Z squared over N squared. The emitted radiation energy clearly scales as Z squared. So P matches with 5, energy of radiation from electronic transitions in hydrogen-like atoms. Next, Q says E is proportional to Z minus 1 whole squared. By Moseley's law, the frequency of characteristic X-rays follows square root of nu equals A times Z minus 1. Squaring both sides, energy is proportional to Z minus 1 squared. So Q matches with 1, energy of characteristic X-rays. Now R says E is proportional to Z times Z minus 1. The electrostatic or Coulomb energy term in the semi-empirical mass formula is proportional to Z times Z minus 1 divided by A to the 1/3 power. For stable nuclei in the given range, A to the 1/3 varies slowly, so the dominant Z dependence is Z times Z minus 1. So R matches with 2, the electrostatic part of nuclear binding energy. Finally, S says E is practically independent of Z. The average nuclear binding energy per nucleon is approximately 8 MeV for nuclei with mass number between 30 and 170. This value barely changes with Z, so it is essentially independent of Z. So S matches with 4, average nuclear binding energy per nucleon. The correct answer is option C. P matches with 5, Q with 1, R with 2, and S with 4. Here are some important tips on Z dependence in modern physics. Tip 1. For hydrogen-like atoms, always remember the Z squared dependence in both energy levels and spectral lines. Tip 2. Moseley's law is key for characteristic X-rays. The screening constant B is approximately 1 for K-alpha lines, giving the Z minus 1 squared dependence. Tip 3. The Coulomb energy term in the semi-empirical mass formula has Z times Z minus 1 because it counts pairs of protons. Tip 4. Continuous X-rays depend on the accelerating voltage, not on Z, that is why option 3 does not match any entry in list 1. Tip 5. The binding energy per nucleon curve is remarkably flat in the middle range, which is why nuclear fission and fusion both release energy. Like and subscribe for JEE Advanced Solutions at MAGPIEHUB. See you in the next video.